I'm Sammy Bump.
And I'm Hannah Carson.
And this is The Physics of Bumper Cars.
How do bumper cars work?
There's a metal grid on the ceiling that's always charged. When the ride operator flips the switch to start the ride, it charges the metal floor with opposite polarity of the ceiling. Each bumper car has a puller in the back and touches the ceiling, and a brush underneath the car that touches the floor. When riders press the go pedal, it completes a circuit between the floor and the ceiling, powering the front wheel and making it spin. When the rider stops pressing the go pedal, it breaks the circuit and the car slows to a stop due to friction between the wheels and the floor.
The pole in the back is usually attached to a spring so as not to lose contact with the ceiling while the ride is in motion. Also, for the wheels on the bottom, the front wheel is connected directly to the steering wheel and controls the movement, while the back wheels are only for stability.
What does the rider feel?
When one car bumps into another, the car stops, but the rider continues in the direction that the car was originally moving. This is due to Newton's first law of inertia, which states that an object in rest tends to stay in rest, and an object in motion tends to stay in motion. Riders feel a jolt because they want to continue moving, but the lap bar prevents them from flying out of the car.
Newton's third law dictates that the force exerted by the first car on the second is equal in magnitude and opposite in direction to the force exerted by the second car on the first. You can see this when you run into someone because you experience the same amount of force that you inflicted on them, but in the opposite direction. Newton's second law says that the force equals the mass times the acceleration. So if you have someone with a big mass, then they will experience a smaller acceleration than a person with a small mass because they're inversely proportional.
The metal floors are smooth to reduce friction as much as possible. The whole point of the ride is to bump around, so it wouldn't be any fun if someone bumped into you and you didn't slide anywhere.
More physics.
Impulse, which is change in momentum, equals the force times the change in time. For a given impulse, if change in time increases, force must decrease and vice versa. This is why they have bumpers on the sides of the cars. The bumpers deform when they hit each other, which increases the time it takes for the cars to stop. Therefore, the force on the riders is lessened to prevent injuries.
The collisions that you have in bumper cars are close to elastic, but you can't have an actual elastic collision in real-world situations because you always lose some energy in any collision. Therefore, the bumper car collisions are inelastic collisions because you lose kinetic energy due to the deformation of the bumpers. Kinetic energy is not conserved, but momentum is always conserved. For the sake of calculations, you can consider the collisions to be elastic so that the first mass times the initial velocity of the first mass plus the second mass times the initial velocity of the second mass equals the first mass times the final velocity of the first mass plus the second mass times the final velocity of the second mass.
When two bumper cars approach each other, they have kinetic energy. When they bump into each other, the bumpers squish, changing all of the kinetic energy into elastic potential energy. After the cars stop, the elastic potential starts to turn into kinetic energy again as the cars accelerate in opposite directions.
Whenever you collide in a bumper car, you and the person that you collided with bounce off in opposite directions due to Newton's third law. But when you bounce off of each other, why don't you keep going? This is because you already lost some energy from your collision, and then you also lose some more energy from friction from between the pole and the ceiling and between the wheels and the floor. Since you're not going at very high speeds, it's very easy for the friction to overcome your inertia and stop the car. This is a free body diagram of what your bumper car would look like. Your bumper car is the square in the middle down here. You have the weight of the car and then the weight of yourself, which is balanced by the normal force at the top. You also have the force of friction, and when you're moving, you obviously have to have some sort of applied force that you go forward. So that's that. Of course, when you stop, the only force you have in the x direction is the force of friction, which is why you eventually come to a stop. That's all for the physics of bumper cars, AP Physics.
Have a great day, and as always,
Go Chargers!
Woo!
Bye.